Welcome back to session 3 of today's PENC Raleigh seminar. Thank you so much for being with us. We will be taking questions at the end of the presentation today. As always, you can type those into the questions box and I will read them out loud for our speaker to answer. Our speaker today is Dr. Morten Barlaas. Dr. Barlaas is a distinguished university professor and head of the Department of Civil Construction and Environmental Engineering at North Carolina State University. He received a BS in chemical engineering from the University of Michigan and an MS and PhD in civil and environmental engineering from the University of Wisconsin in 1988. He started his academic career at NC State in 1989 and has been serving as department head since 2010. Dr. Barlaas has been involved in research on various aspects of solid waste since 1983, including biological refuse decomposition, methane production, and the biodegradation of hazardous waste in landfills, policies for the long-term management of landfills, and factors contributing to heat generation and accumulation in landfills. He is also recognized for his research on the use of life cycle analysis to evaluate emissions associated with alternate solid waste management strategies. Dr. Barlaas is the author of over 150 peer-reviewed publications and has made hundreds of presentations at conferences throughout the world. Thank you so much for being with us.
Good morning. Good morning to everybody. Glad we have, looks like a group of 80. Today I'm going to be putting on my department head talk and talking to you about the Department of Civil Construction and Environmental Engineering at NC State. I'm sure that many of you are alums. I'm sure some are not, but we'll all learn a little bit about the department. For those of you that are unaware, Mann Hall officially closed in December of 2020. Our new home is in Fitzwillard Hall, which is right next to the Hunt Library on Centennial Campus. And we're just thrilled to be here. Mann Hall was designed in 1963 for a 50-year life. So we got that in a few years more, and we're just thrilled to be in a new facility. A little bit more about the building later in this set of slides. I think one of the big things I like to start with is starting in August 2021, we're back on campus. All but 2 of our classes were taught in person. We had a couple classes taught online, but all of our classes were taught in person. It's great to have students back in the building. And I won't say things are normal. There are mask requirements indoors and certainly a lot of care and a lot of testing, but we're just thrilled to have students back in the building and using the building. We did miss 3 graduations, spring 20, fall 20, spring 21, and we did have people back in August for an informal get-together just to recognize the missed graduations. We do have a department graduation at McKimmon Center next Monday, so again, we'll be doing that for the first time in 2 years, and I never thought I'd say I'd be looking forward to shaking so many hands again, but I am. With that, just an outline, I'm going to talk briefly about faculty and staff and give you a sense of who we are. Talk a little bit about our undergraduate and graduate programs, research, some faculty accomplishments, and then maybe a little deeper dive into our research programs. We're about 50 faculty, and I'll be the first to admit that this picture was taken before COVID, and kicking myself for having not gotten a current picture right before we moved, but I didn't want a picture with 50 masks. So we're still working with an older picture, about 50 faculty, 2 lecturers, an extension specialist, and probably about 20 or 25 postdocs and visiting scholars here on sabbatical. Some of our newer faculty, Catherine Inarde, joined us in August. Her area of expertise is coastal engineering. After graduating from Rice, she actually spent time at UNC in a postdoctoral position. And as I say, joined us in August in the coastal area. with a focus on coupling human and landscape interactions and understanding changes during storm events and over short to medium term timescales that capture various effects of climate changes and policies. And then Andy Ziccarelli. Andy is here and actually starting officially in January, doctorate from Stanford. He's in the structural engineering area. He's had, in addition to his academic experience, almost 5 years of experience in the industry. And his focus is on the analysis and behavior of steel structures, and also innovative analytical methods to simulate fracture and low cycle fatigue in metal. So these are just the two of our newest faculty. To give you a sense, I've been department head since 2010, and I think we've hired about 22 or 23 faculty. So roughly half the department has transitioned over the last 12 years, and that's been a lot of fun and exciting. On the staff side, there's also been a good bit of transition. We have 11 staff doing undergraduate and graduate programs, grant management, personnel, IT, the machine shop, lab managers, and a foundation officer. Here too, many of you may remember Tony Pascucci, who was in our undergraduate programs assistant for many years. She retired a few months ago, and Rachel Clark has replaced her. And then Jake Rhodes, who ran our machine shop for many years, retired. And Ahmad Tuardos is now running our machine shop. Beyond that, just like in the private sector, we too are experiencing more turnover than we have in the last decade, and smaller applicant pools. And we're actually looking for 2 people in our business office now. So we have vacancies and are struggling a little bit with workload because of vacancies. But let's talk about the department. As you all know, civil engineering is very broad. And we tend to divide a little bit into specialty areas, which are listed here. Structures, environmental, which includes water resources and coastal engineering, transportation systems, as well as transportation materials, geotechnical engineering, and construction engineering. And most of our, not most, all of our faculty align with one of these areas. We also have some cross-cutting areas, one mechanics and materials, which brings together faculty interested in different engineering materials, whether that's cement, concrete, or soil, but they're interested at a mechanistic, very mechanical or fundamental level across these engineering materials. Then, of course, new composites also fit in that mechanics and materials description. And a computing and systems group. These are people, again, with an implication of with an interest in the application of high performance computing to civil engineering problems. So we have faculty, whether they're interested in computational mechanics or hydrology or air quality or autonomous vehicles, all with an interest in applications of computing to those civil engineering domain problems. We also have 2 clusters. We'll come back and talk about these later, one in energy systems and policy and one in global sanitation. And I'll come back to those later in this presentation. We're a very large department. If you look at the American Society of Environmental Engineering list of degrees awarded by school, you see us ranked 13th at 148, but if you take the 148 and you add our environmental engineering degrees and our construction engineering degrees, that brings us to 195. So you can see we're in terms of department size, we're probably a top 5 or 6 department. And as a college, the College of Engineering ranks 9th in degrees awarded with 1,800. So we're big, and I point that out because, of course, it means that we're having a significant impact on engineering practice just by virtue of the numbers of students that we're graduating. Of course, big isn't the only thing. We're strong, and these rankings are not the best indicator. Of course, I'd rather be higher than lower. But these rankings they're a little bit of a beauty contest. So I don't lay in bed at night worrying a lot, but we're a top 10%. Again, you see 30th and 31st in civil, environmental 22nd, graduate a little bit, undergraduate is greater than 25th and they stopped ranking, but we're very close to 25th, if not higher. There is no ranking for the construction engineering program because there are only 17 in the country. We're consistently listed as a best value, and in our online program is ranked very high. We'll again come back to that a little bit. We offer undergraduate degrees in civil construction and environmental engineering. The 595 is sophomore through senior. The 772 includes freshmen. And you can see how that breaks out, with construction being a relatively small degree. And I might add that we have any number of civil engineering majors that actually go into construction on graduation. And then there's maybe about 20% environmental and about 75% civil, very, very roughly in terms of the breakdown. But we're all one department. There's overlap in courses. So the differences are just in the degree granted. And then on your right are some pictures of a new classroom and a lobby in Fitzward Hall. We've initiated an ambassador program, and these are a select group of undergraduates that represents us at open house. Sometimes we get requests for meetings with high school students, a whole variety of events through the year, and these students are just fantastic in representing the department. And I love I'd rather have a 20-year-old talk to a 17 or 18-year-old than some old guy like me. So this is working really well. Our student groups are numerous. You can see the list on your left, everything from the traditional ASCE to the Earthquake Engineering Research Institute to the Women's Transportation Seminar, and on and on. I would say that our groups were going very, very strong before COVID. We've taken a hit here because we were frankly a little bit inactive for about a year when students were taking classes remotely. The idea of Zoom meeting student groups didn't go well. And what that means is that we had a group of leaders graduate without some institutional memory, which we would normally have liked to have. So they're active again, but frankly slower than before COVID, and I think it'll take us another year to two to recover. At the graduate level, we offer a Master's of Civil Engineering. This is a courses-only degree in civil and in environmental. And we also, again, we have a large graduate program in construction, but the degree is named civil. The Master of Science is a thesis-based degree where students are involved in research. We have a distance education master's and, of course, a PhD degree, which is research intensive. We're at about 301 graduate students. That includes probably 60 to 80 that are online only. That number is down about 10% from the year before, strictly due to the fact that even last fall, there were delays in getting people in the country, and we have a significant contingent of international students. The other trend you'll see here in the upper left is over the last 6 or 7 years, there's been maybe a 17 or 18% increase in PhD students. You're seeing some drop off in master's enrollment, both on campus and distance ed. The on campus, I think this is strictly due to the job market. There's just such demand for students that fewer are interested in a master's degree. And the drop off on the distance ed side is frankly a whole lot of universities have started up programs, and so there's more competition, which means we're getting fewer out-of-state students. And you'll see, degrees granted. The master's has dropped off, and then as we see this increase here in the green bar, I expect we'll see an uptick here in another year. One of the things that we've done is we've hired a graduate director of professional development, Megan Kittle-Autry, has a PhD in communication. She teaches courses in technical writing, as well as does a number of workshops to talk about some of the softer skills in research and professional. She's been with us for 2 years or 2.5 years, and she's been very popular with the graduate students. The program has been so successful. What I'm trying to do is extend it more to undergraduates. And what we have done is what we've done is actually hired a TA in technical communication to help work with one undergraduate lab class, again, to look at how we can help build up technical writing skills, which we know is a challenge sometimes for engineers. I mentioned that we have online programs. We're offering about 15 courses a semester. This is the list of courses we'll be offering this spring. It's actually more than 15, although truth be known, some may not fill. And you'll notice I mentioned this communications course, which Megan teaches online, in addition to a wide array of engineering courses across each of the specialty areas. If you're perhaps interested in you or some of your employees, we have a number of videos on our website that you can look at to learn more about our program. And we're also happy Dr. Jim Levis is available to either visit with you or meet by Zoom or on the phone and talk about our distance education program. He's kind of our liaison from the faculty to the civil engineering industry in terms of providing information on our engineering online program. So if you might be interested, you can contact me or Jim directly to get more information or ask questions. So I want to now switch gears a little bit and talk some about our research program. And I'm going to do an overview first, and then come back with more detail as time permits. We're a large department, and that means that we're able to cover lots of areas. So I've listed our specialty areas across the top: computing and systems, construction, environmental, water resources, and coastal, and on and on. So at the master's or PhD level, you're typically specializing in one of these areas. There are some students that are taking more distributed degrees, but typically you're specializing in one of these areas. And we're working from, I like to say, from nanoscale to field scale. The lower left is work to understand genes that are in bacteria in wastewater treatment plants that are treating domestic wastewater. So that's the molecular level, and you need microscopes to see it. But then we scale up. Here's an accelerated pavement testing test. So we might think of that as pilot scale or large lab scale. The lower right is a soil flushing field project where we're demonstrating a technology at field scale. And then this picture in the upper right, looking at energy efficiency and transportation, and then this plot on the right, or not plot, but figure on the right. These are faculty that are working on issues with implications for national policy, whether it's the energy grid or transportation systems. So I like to say we work from nano to field scale, and everything we do is related to the design, management, and operation of sustainable infrastructure all over the world. And we've got just a broad array of faculty doing lots of different things. One metric or a couple metrics that we use are research expenditures, and both total and our contracts have been increasing. This is a good sign in terms of our faculty's competitiveness. Another sign that I use is where's our funding coming from? And I'm really proud of this. You'll see that 48%, 16 and 32, is federal funding. This is the most competitive funding. And I like to point out that, you know, if you write a 15-page single-space proposal and it's perfect, you have about a 20-25% chance of success. Anything less, don't waste your time. So this is a great indication of faculty competitiveness. But there are other important points here too. 22% of our funding is from the private sector, and I like this because it means we're doing things that people need. The private sector is investing in things that or research questions where the answer can affect their operation over a 2 to 3 year time frame. About 16% of our research funding comes from the North Carolina Department of Transportation, again, a mission-oriented agency. So we're, again, solving real problems. And then the rest, just a variety of sources. Illustrative funding sources are listed here, and you'll see everything from foundations like the Bill and Melinda Gates Foundation to agencies like Defense, Energy, Homeland Security, the National Science Foundation, as well as some foundations, Environmental Research and Education, the Sloan Foundation, and on. So just a wide variety of sources, all of these receiving competitive proposals. I'm just going to flip through a few examples of research in the news. This is a headline from the Raleigh paper. A few months ago, one of our faculty, Angela Harris, who's only in year 4 now, she went right out into the field as soon as it was safe after Hurricane Florence and started collecting data to understand sources of fecal contamination. And of course, we publish in scientific or peer-reviewed journals. I'm going to move my camera. I just see that the sun hit it. There we go. But also, a lot of what we're doing is policy relevant and gets picked up by the local press. In this case, can inform things like management of hog waste lagoons. We recently, we includes both civil engineering as well as material science and engineering, won a 5-year, $25 million center proposal from the National Science Foundation. These are just huge. The focus is phosphorus sustainability, but coming at it very holistically. The involvement and leadership of material science has to do with methods for recovering phosphorus. 4 of our faculty, Doug Call, Detlef Knappa, Dan Obenauer, and Jim Levis, are playing key roles in this center. Shane Underwood in our asphalt group was on CNN, albeit briefly, but CNN did a piece on climate change and infrastructure, and Shane's been working with the Arizona DOT on the impact of rising temperatures on asphalt in roadways. The National Science Foundation offers what they call rapid grants. These are funding for time-sensitive research, and one of our faculty, Ali Hashababe, who joined us from Washington State just before COVID, along with collaborators in industrial systems engineering, received funding to collect data on the distribution of COVID vaccine allocation. How do we allocate, distribute, and ship? So, you know, very exciting, something that they wrote quickly. And we're successful. And I might add that this work here, again, we started it with seed funding from the department, but then NSF, once they saw the work, also contributed And then finally, this is the cover page from a New York Times article on PFAS, per and polyfluoroalkyl substances, which if you've heard of, sometimes referred to as forever chemicals. For those of you that might have heard of Gen X, which was the chemical out of the Chemours plant, which was identified in the New Hanover County drinking water via the Cape Fear River. Gen X was discovered in our laboratories. And Detlef Knappa is featured in this article for leading a good bit of that research. This is a first for us. This is a release from the White House briefing room. It's from September. Two of our faculty, Joe DeCarolis and Chris Frey, have been nominated for Senate-confirmed positions in the Biden administration. Chris will, in essence, be the chief political appointee who is serving as a science advisor to the Office of Research and Development at EPA. And Joe DeCarolis has been nominated to be the director of the Energy Information Administration, which will report directly to the Energy Secretary. If you want to know what EIA does, think back to the Colonial Pipeline when there was a disruption and people wanted to know where everything was, where our energy was coming from. They went to the EIA, but they do much more than that. So, bottom line, I am just thrilled that two of our faculty have been selected for such prestigious positions, and it speaks a lot to the hiring decisions that we made over the last 25 years. Some awards, just to give you a sense. Ashley Kabas is in our geotechnical group and just won a major award from the Earthquake Engineering Research Institute to early career faculty poised to make major contributions in earthquake risk mitigation. Francis de los Reyes was selected to join the National Academy of Science and Technology in the Philippines, as well as a Patents for Humanity Award for his work on a pit emptying machine to clean out pit latrines in developing countries where they don't have access to third world, to first world sanitation. We talked about Chris Frey. He was also recognized with a major internal award. Andy Grishop won a Global Wage Engagement Award for all his work on indoor air quality in developing countries where people are using cook stoves. Fernando Garcia won the College of Engineering Advising Award. Richard Kim won a national award for his work on characterization of transportation materials, and so on. I won't read the rest of these, but what I'm trying to do is paint a picture of a highly accomplished faculty working on real problems and solving real problems. And it's not just our faculty. Laura Dalton is a PhD student who was awarded a Fulbright to spend a year studying at the University of Eastern Finland, where her advisor has a lot of collaboration. Minerva Bonilla, again, won an award from the National Science Foundation to spend a year at, I believe it's the University of Calgary. And then 3 of our graduate students won NSF research fellowships. The success rate on these fellowships is less than 1%. So these are the top of the top, and we're just thrilled that 3 from our department were awarded graduate research fellowships. We've had some high profile events. Here's a picture of Pete Buttigieg in the blue suit, and then Doug Himoff. We refer to him as the second gentleman. This is Kamala Harris's husband. They visited in late April, along with David Price and Deborah Ross, our local congressional representatives, for a tour of just trying to gain an understanding of the research that we do in the area of infrastructure. So they visited an asphalt lab, as well as the constructed facilities lab. And I got some one-on-one time with Pete Buttigieg walking between Fitzward Hall and the constructed facilities lab. And the lesson here is I've never buttoned my jacket, and I guess I should have. But nonetheless, it was a very successful visit. More recently, this is me, this is Governor Cooper, Beth Visor, who is the Secretary of DEQ, and Michael Regan, who is the US EPA Administrator. He was formerly the Administrator of the North Carolina Department of Environmental Quality. They came to NC State to make a major policy announcement on PFAS. And then we got about an hour and a quarter of touring the environmental lab and learning about what we do, not just in civil engineering, but across campus. So again, successful, high profile, and it's, here we've got Detlef Knappa in front of a screen giving the governor and Michael Regan a little chemistry lesson on PFAS. These are probably once in a career type events, so we're pleased with that. Switching gears a little bit, in terms of budget, there have been impacts. The move had all kinds of impacts. COVID has had all kinds of impacts. Faculty and staff salaries have fallen way behind, frankly, and this is causing issues. I mentioned we had vacancies, and there's a direct correlation here. As you may know, the state did just pass a budget, which will, I think it's 5% raises over 2 years. But that too, if you go back over the last 6 or 7 years, the average is well under that 2.5% a year. We have ongoing searches in the structural and materials engineering area, as well as in soils. And it's public knowledge. I've been the department head since 2010. I'll be stepping down hopefully by June 30th as we recruit a new head, and that search is ongoing. And that is a national search, and we'll look forward to all of these searches a successful conclusion. We've been running a career fair. It's been virtual since COVID started, and we're finding employers actually prefer it virtual because they can add people as they need them. We had 62 employers for our fall career fair. The spring career fair will be in February. And these are just some statistics in terms of number of meetings, number of people that had more than one meetings. We involved other schools in North Carolina. A is a courtesy, and B, frankly, to try to help employers get more access to more students. So we invited Duke, A&T, and UNC. And then I learned that once we put it on the web, anybody can register. So we had one from Georgia Tech and one from Virginia Tech, one from Wake Forest, and that's fine. I see it as a good thing if students from other engineering programs are coming to NC State. The building, if you're interested, there's a virtual tour at this website. It's on our website. So if you click around, you can find it from our website, or you can take a screenshot and go to it here. But the labs are great. All the infrastructure works, the air conditioning works, the heat works, the fume hoods work. We have a separate space for our student groups where they're building things for competitions. We have all the labs you'd expect: environmental, composite materials, asphalt, soils, construction. We have a new flume in the hydraulics lab. We have a new hydraulics teaching lab. So the labs are Manhall was basically outdated and obsolete, and it's just great to be in a facility that's got new infrastructure, and I love to say we'll serve students that haven't been born yet, and it's a great feeling. The department has a Hall of Fame. To give you a sense, we're roughly at looking for the top 1% of our graduates. Our first graduate was 1896. We have about 14,000 graduates. Just to give you an idea, Dr. Abdel Malek was the CEO of of Montgomery Hazra. Susan Beckstoffer directed engineering for Newport News Shipbuilding. Otis Crowder, of course, developed Crowder Construction. David Johnston is a retired faculty in our construction area whose contributions over his career, not just to the department, but to the construction engineering field and ABET accreditation and the PE exam, have just been tremendous. Carol Lamb is the man for whom Mann Hall was named, and we wanted to memorialize his name as we move to Fitzward Hall. Bill Marcuson is a member of the National Academy of Engineering and directed the Waterways Experiment Station in Vicksburg, Mississippi for many years. Doug Morton is a retired Rear Admiral who is now our Vice Chancellor for Facilities. Lonnie Poole founded Waste Industries. It's been taken over by GFL, but he built a multi-billion-dollar company. Wayne Stocks is the president of Thornton Tomasetti. Mike Gwynn had senior leadership roles at SAIC, Benham, and a couple other construction firms I can't think of, and has also played a huge role in ABET. Jim Hips was a senior manager at a senior executive at Black & Veatch. Retired Rooney Malcolm, who's deceased, but many of you may remember as a professor in hydrology. David Simpson founded Simpson and Associates. Larry Twisdale built the Raleigh office of ARA, which is something Research Associates, and just had tremendous impact on wind engineering. And Debbie Young rose to a very senior leadership position at Honeywell before retiring. So it was just a great ceremony and a fantastic group of people. And if any of you have ideas for nominees, I'd love to hear from you, or you can nominate via our website. So let's just spend a few minutes. I wrote a deeper dive, and I just grabbed a few slides from a presentation on all of our ongoing research, and that, again, you can link it from our website. It's a little bit long, but I'll help you find it if you'd like. First, I said I'd talk more about our two clusters. The Chancellor established a cluster program where we would hire groups of faculty across different departments. And these were competitive. And two of our faculty led successful cluster proposals. One led by Francis de los Reyes on global sanitation. And his impact here has just been amazing. He has a TED Talk with, I think, 890,000 views. It's been translated into 20-some languages. And then Joe DeCarolis, the faculty member who will be hopefully confirmed as the director of the Energy Information Administration, established a cluster on energy systems and policy. A little bit more detail here, the energy systems, everything, looking at all dimensions, political, social, economic, environmental. And he's got people in economics, someone in humanities, someone in electrical engineering working as part of this core group, just doing great work. And similarly, the global sanitation group I mentioned, Francis has already won multiple international awards for his work and literally improving people's lives through the work he's doing to bring better sanitation to developing countries. More broadly, I'm just going to take a snapshot of each of our groups and try to wrap up in maybe 6 or 7 minutes. I mentioned a computing and systems group with faculty with expertise in core computing, as well as some domains, structures, coastal, whatever. And look at where our graduates are going. SAS, Cisco, IBM, Microsoft, not where you would typically think of for civil engineers. But they're doing very significant work in algorithm design, programming, software development that is attractive not just in the civil engineering domain. This is just one example of research in the water resources area using computational tools to detect leaks, detect contamination, and work on risk assessment for water distribution networks. And I'm sure some of you have heard there have been some attacks on water distribution networks ever since 9/11. So this is not just some theoretical research exercise. I'm not going to go over the details. I'm just going to try to focus on the questions that we're trying to answer. In construction, again, just one project, trying to improve efficiency in monitoring, reduce cost overruns, reduce scheduling delays through the use of visual analytics, cameras and robots to monitor projects, integrate that with building information modeling to better track projects and understand potential hangups and intervene early. Also applications in construction safety. In the coastal engineering area, looking at prediction of storm hazards, trying to assess storm surge and flooding at many spatial scales. And Casey Dietrich, who's leading this work, works very closely with the North Carolina Department of Emergency Management when a storm is coming. So it's sophisticated computational work, but real applications. And as I say, working with the North Carolina Department of Emergency Management, using a variety of tools here, and it's not just computational. There's field work, there's sensors that are going in. You know, one of the challenges we have here is, you know, how many sensors can you afford to lose in a storm? But integrating field observation with computational modeling. Water resources and environmental is big. So I'm just listing the different areas from air quality, which is everything from aerosols to vehicle emissions, water, a variety of different activities from the traditional water and wastewater treatment to microbial ecology to new material design to remove trace organic contaminants from water to the work on global sanitation. Solid waste is another, that happens to be my area. I do a lot of work on landfills and a lot of work on waste management alternatives. Energy systems, looking at emissions from various technologies, building energy efficiency, and systems optimization. And of course, that ties to climate. But we're also working on climate change and watershed impacts. Sankar Arumagan is a hydroclimatologist. So we're very broad. Here's just one example I mentioned earlier. The Gen X, which is given here, was discovered in our labs. We're looking at removal mechanisms and also at analytical methods to identify the next Gen X, to characterize trace organic contaminants. And you see, again, a few others, dioxane and trichloropropane, other contaminants that we're working to not just detect, but to remove. In the environmental, the geotechnical area, just talk about one project on cement, the application of biocementation to stabilize coal ash ponds, including the heavy metals. So a new method, biocementation, is being looked at. And again, ash ponds have received a lot of attention in the last 4 or 5 years, and another example of a need for a new technology. And Dr. Montoya is working not just in the US, but in a mine tailings project in South America as well. In the structures area, again, very broad, from computational mechanics to rapid repair. So just one example here of a rapid repair of a column that was damaged in an earthquake. And of course, I don't have to tell people rapid repair means restoring infrastructure faster, which is less disruptive for society. We actually now have, I think, 7 funded projects from the Alaska DOT because of our expertise in seismic control, seismic safety and earthquake engineering. Here's another example of a large area sensing skin that can be used to monitor infrastructure for cracks and also for infiltration of chlorides, which can lead to corrosion. More fundamental, at the Mechanics and Materials Group, I kind of explained what they do earlier, but here's a really interesting project looking at non-destructive testing using wave propagation algorithms to detect structures. Murthy Gudati is using this to look at depth of bridge foundations, to look at soil structure interactions, to look at damage. And most recently, it says here medical imaging. He's actually been working with biomedical engineers and with doctors at the Mayo Clinic in Minnesota to use these same methods to detect stiffness in human arteries, which is another way to think about non-destructive testing, I suppose. And what's beautiful here is we go from fundamental research funded by the National Science Foundation, not in engineering, but in mathematics, all the way to impacts on civil infrastructure and human health. And those are great stories to tell. Transportation materials, again, we've got a very big group working at everything from national policy. The Federal Highway Administration has literally adopted the performance specification methods developed in our lab have been adopted by FHWA, as well as I think, I forget the number of countries, but several other countries. So all the way from national policy down to through all the different aspects of pavement to mechanistic information on properties of the individual components of asphalt concrete. And then in transportation systems, working on everything from transportation access and gentrification to connected and autonomous vehicle research, capacity manuals, national guidebook on travel time reliability. So again, lots of different things going on, including, as I mentioned, how vehicles, autonomous vehicles, communicate with each other and with a mix of autonomous and non-autonomous vehicles. So I can't close without offering opportunities to help through our enhancement fund. We use external support for all the things listed here. We also have opportunities to sponsor our newsletter or various graduate symposia or our Welcome Back ice cream. And we're still a little bit in debt on Fitzward Hall, and happy if people are interested in naming a lab or a classroom. Finally, there's our website. We have a LinkedIn page. We're on Facebook. We're on Twitter. We're on Instagram. If you're not receiving our newsletter and would like to, I'd love to hear from you, and I'll be happy to put you on our newsletter list. So with that, I'll thank you for your attention and interest, and I'd be happy to take any questions or talk about anything else if you'd like to.
Great, thank you so much. We do have a question in the chat. Do you think the new building will in any way affect the national ranking?
Probably. You know, I like to say 2 things about national ranking. One is it's part beauty contest. And I've been accused of a lot of things. Beauty is not one of them. It really is, you know, some of it is perception. And that perception comes from department heads at other schools, as well as high school guidance counselors. So we do things like we mail the newsletter, a hard copy to every department head in the country. I take every opportunity to promote the department. That said, I'm quite sure that the new building will help us with our rankings. We've done things to get get the word out. We're actually hoping to host a conference here in a couple years. So I think it'll help, but it's also, there's some randomness and some, there's just some randomness, so it's a little hard to predict. What I'm proud of is if you look at where our research expenditures are, look at where they're going relative to where they've been, looking at the national competitiveness of our faculty, look at the fact that we've got that phosphorus center. We're actually in the final selection for another major center. So I'm actually quite confident that we're stronger than our rankings. But I want to let our research and education do the talking and take advantage to promote when I can.
Okay, great. We do have another question. What is the plan for Man Hall?
The plan for Man Hall, the immediate plan is the rebar inside the concrete columns is corroded due to water infiltration. And the immediate plan is a significant rehab of the columns. And I believe that work is going to start in January. And my understanding, not being a structural engineer, but I'm told that that will get about 10 more years of life out of the building. The building is also surrounded by scaffolding because there was a little bit of concrete coming off the top, and as a precaution, scaffolding was put in to protect somebody from getting hit. In terms of who's moving in, I don't know, and I'm not sure that the architect's office knows. What I have found is that space on campus is dynamic, and for example, when mechanical engineering moved out of Broughton, people were basically swearing over their graves that nobody else would move in Broughton. Broughton was closed. It was too expensive to operate. 3 years later or 4 years later, the College of Science Dean's office occupied Broughton. So space is dynamic. As a university, I think it's fair to say that our biggest challenge is space. We just don't have enough. The fact that this building is full, even though we just moved in, is a good example of that. The university in the state budget did receive, I think it's 30 million, but please no, it's more than 30 million. Don't quote me on the number, but we did receive significant repair and renovation money in the new budget, and we need it. So I don't know who's going to move in. It will not be engineering. It'll probably be sciences, but I'm not sure.
Okay, I think that's all of the questions that we have. We really appreciate your time today. Thank you so much for being here.
Well, it was a pleasure. I always enjoy talking about that which I'm proud of. I hope people enjoyed it. And again, please feel free to reach out if you're not on our newsletter list and would like to be. And thanks for your interest and best wishes for the holidays.
Great, thank you so much. All right, everyone, we are going to take our lunch break. We will be back at 1:30 p.m. With Myths versus Facts in Nuclear Science and Technology with Robert B. Hayes. I will see you all then.